Yes, ma'am.
You have done this too?
Yes, ma'am.
Yes, ma'am.
Okay, these two are examples in Jain anger. So, okay, we will do the solution. Okay. So, any one of you tell how we do. Okay. So we have find the curvature and radius of curvature. Okay. So in the first one, it's a parametric equation. So x equals to a cos cube t, y equals to a sine cube t. So in parametric equation, what is the formula for the curvature? What is the formula for the curvature? X dot or x
Uh,
dash? Yes.
X dash y double dash minus x double dash y dash
And divided
divided
by
by x dash square minus y dash square whole power 3 by 2.
plus y dash square all power 3 by 2. So we have to find the derivatives. Okay. Right. Okay, so what is x dash? X dash means we will go for dx by dt. So how much it is?
Minus dA by 2 root 2. By 2 root 2.
2 root 2. Okay, just a minute, 1 minute. Okay, so what is y dash?
3a by 2 root 2.
Y dash is 3a by 2 root 2 and y double dash. divided by x dash square plus y dash square 3 by 2. So how much is it? Finally you are getting? Anyone who has done? Tell me. What is curvature? Solved any of you?
2 by 3a.
2 by 3a. Others, are you getting the same answer? 2 by 3a?
Yes,
Okay.
ma'am. 2 by
So
3.
radius of curvature is 1 by k. It will be 3a by 2. Okay. It's same.
Yes, ma'am.
Okay. So for the next question, solution, we have r is a cos theta plus b sin theta. So r is a cos theta plus b sin theta at any theta. Okay. So here, so how you did it?
Find R1, R2, then curvature.
Okay. So what is R1 and R2? So R1 is the first order derivative and R2 is the second order derivative. Okay. So R1 dr by d theta, and here this is d2r by d theta square. So what is the formula for the curvature?
R square plus 2R1 square
R
minus
square
RR2.
plus 2r1 square minus r2 and
Yes.
divided by.
R square plus R1 square to the power 3 by 2.
So after substituting, what is the answer?
2 by root over of a square plus b square.
2 by root over of a square plus b square.
Yes, ma'am.
Okay. 2 by a square plus b square. So we'll write it half. And the radius of curvature is the opposite. Okay. So we have done this curvature and radius of curvature. Okay. One more problem here. Okay. So I think now it's clear how we do it. Okay. Okay. So you find the radius of curvature. Curvature and radius of curvature. Okay. Okay. So the first one, x equals to e power t plus e power minus t. Okay. And y equals to is the opposite. We will change the sign, e power t minus e power minus t. Okay. So now you find the curvature at t equals to 0. Okay. And one more question, you can do it. X equals to ln sec t plus tan t. Y is a sec t.
Then we have to write in x equal to f of y.
First one 1/2 2.
First one 1 by 2, 2. Answer your
Ma'am, curvature is equals to 1 by 2 and radius of
okay. Okay, dx by dt becomes 0 at t equals to 0. Okay, that's right. Curvature is 2 and radius, sorry, 1 by 2. Curvature is 1 by 2, you said?
yes, ma'am.
Okay, and radius of
Yes, ma'am.
curvature is 2. Can you do the next one?
Yes, ma'am.
So x dot and double okay, and y will be
Excuse me, ma'am.
Yes, I did some mistake. Any mistake?
In question 2, we have to find the at p equals to 0 only.
So you have to do the calculation. I have written, okay. And now the second one, solve it and tell me.
Ma'am, in question 2, what is the value of t given?
Nothing. You do it.
Okay,
You
okay,
find
okay.
a general. Actually, you find a general form so that once you have the general expression at any value of t, you can substitute. Okay. Just find the
Yes, ma'am.
general expression.
In question 2, k is equals to cos square t and r is equals to sec square t.
K equal to A tan T sin square T.
Yes. What happened? How much you are getting?
K equal to A tan T sin square T.
K equals to tan t sin square t. And r
1 by K.
tan t sin square t. Just a minute.
Ma'am, I am getting k is equals to cos square t only.
A cos square t or 1 by a cos square t?
And only cos square t.
A is not there. And I'm writing the calculation directly. Okay, you will do. So x dash we are getting a sec t So the second order derivative, if you see, it is coming a sec t dot tan t just equals to y dust is a sec t tan t. Sorry. How much is the double derivative?
Same, ma'am. A
A sec
secant
t tan t.
And y for y?
A into
A sec t into tan square t plus x cube.
secant cube t plus
Second cube t
plus
or
tan square t secant t.
sec cube t plus tan t into sec squared
Tan square t
tan
into secant t.
second or tan square into second.
Yes, ma'am.
Okay. The up to this
Yes,
everything is right. Okay. So a second we're getting cos square. Okay, I didn't do the calculations. You have to do. Okay, you have to do all the simplification. And the radius of curvature is 1 by curvature, so it is a second square t. Okay. So you also do for one polar form. Polar form 1 we have done. Okay, on one question. So the radius of curvature at any point r theta on the curve r square. R square equals to a square secant to theta. It's proportional to r cube. find the radius of curvature, and if there any r cube term, its proportional means must be at least in the denominator it will be r cube term or the powers of r cube. Okay. Done, anyone?
Yes, ma'am. Radius of curvature r cube by a square.
Okay. So what is the value of R1?
A root over of sec 2 theta into tan 2 theta.
How much? Again.
A root over of sec 2 theta into tan 2 theta.
R1 is A root over of secant 2 theta into tan 2 theta. This is.
Yes.
Others, the same thing.
Yes, ma'am.
So you can also write here as R tan 2 theta. Can you write it as R tan 2 theta? But derivative, or you can also consider the logarithm and find out this R1, okay, in both sides. That will be much easier, I think. Or you're doing directly. So it's up to you, whichever form you want, you do it, okay. You can also take logarithm both sides and then so once you have R1 as R2 theta, then R2 is also easier. So how much is R2?
R into 2 plus 3 tan square 2 theta.
2 plus 3 tan square 2 theta.
No, ma'am. R into whole into 2 plus 3 tan square 2 theta.
2 plus 3. It's R into I'm getting tan square 2 theta plus secant square 2 theta. And is it 2 plus 3 if you break it? Okay. Like if you
Yes, ma'am.
reduce it to whether you are getting the same thing. Tan square 2 theta plus 2 sec square theta.
Ma'am, 2.
I think you will be getting. Okay. So here it's up to you. You can also consider as right 2 in R. I'm only writing so that it will be a little easier. Okay. So this is how it is. Okay. So how much you are getting for the curvature? Radius of curvature is coming r cube by a square. That's what you said, no?
Yes, ma'am.
R cube by a square. So it is proportional to r cube. Okay, it's here we have r cube. Now one more question you do. So determine the radius of curvature r at any point r theta. R at any point. So curve is R power n, n power sine n theta. So deduce R for the curves. R equals to A sine theta. Then R square equals to so here. Okay, so find it.
And that is sine 2 theta or sine square theta.
Sine square theta. Oh, it's sine. It should be sine 2 theta. Yes. It's you first you find the curvature, radius of curvature for this one. Then just substitute n equals to 1, you will be getting this, and for 2, you will be getting this. Okay, that's the idea. Okay, this is equals to. Okay, try. Done? Any of you? So what is R1?
R cot and theta.
Okay. Done for the radius of curvature. So what is for the nth form? The radius of curvature.
Ma'am, it came as a to the power n by n plus 1 r to the power n minus 1.
Answer you're talking about. Radius of curvature. Can you repeat?
Yes, ma'am, a to the power n by n plus 1 whole r to the power n minus 1.
Okay. Then you can find for n equals to 1, the first one, for how much is coming.
Yes, ma'am. Yes, ma'am, finding.
So the equation is like this. Okay, then you go for, as I said, if you consider log, it will be a little easier to do the
Yes, ma'am.
ln r, and it will be n ln a plus
Plus
ln sin
log.
n.
Log. Sin
So now if you differentiate with respect to theta, it will be easier. And how much is R1?
R
You are done now.
R cot n theta.
dr by d theta. R cot n theta. And R2
minus Rn
minus Rn.
cosecant square n theta.
R for n. Rn means, or the product Rn.
Rn
Product.
not
Rn product, no?
R into n.
yes ma'am.
Hmm.
Then
Minus cosecant square n theta.
minus
Cosecant square
cosecant
n
n theta. This much. R cot square n theta minus nr cosec square n theta.
Yes, ma'am, that is coming. The one you wrote.
Okay. And this one. Is it coming? Let's check your calculation. Okay. Now once you have, if you want, you can like for R we have this denominator, I think R1 square plus R square power 3 by 2.
Hmm.
Okay. Then R square plus 2R1 square minus RR2. So if you want, you can find individually. And what is the answer you are getting at the end? One plus n into r power n minus 1. Okay. So if you want, I am also giving you this for this much value. Okay. It is. So this value will be r cube cosec cube
Yes.
n theta. Okay. And the denominator term, so this term is coming r square into 1 plus n bracket 1 plus n. Then we have cosec square n theta. Okay. So you have these values. Now R value also you have. Okay. So for n equals to 1, R will be A by 2, A by 2. Okay. Let's put in the question you see. If you put n equals to 1, you will be getting this, and for n equals to 2, you will be getting this. So you will have a standard form, so directly we will be putting these values here. Now r will be a squared by 3r. I'll try just check. Those who have solved, you can verify 3r or 2r, what is it? Done? Others? Any doubt with this? Only the calculation, okay? Little bit calculation you have to do here, otherwise nothing. Formula directly you substitute it, okay? So it's time, okay? So I'm ending today's. So I'm ending the class now.
Thank you, ma'am.
Okay.